Right then, let's have a look at how we would convert out of standard form, out of scientific notation, if we're dealing with these small numbers, and we can tell it's a small number because it has a negative power of 10. So if we want to convert that into a decimal number, i.e. out of standard form, how are we going to deal with that? 5.0 times by 10 to the negative 2. I'm just going to backtrack slightly and say, supposing we were looking at 5.0 times by 10 to the 2. Well, we know 10 to the 2 is 10 times 10, which is 100. So if we were to do 5 times by 10 to the 2, take that out of standard form, that is 500. What we've done essentially is we've taken that 5 and we've moved its position 2 places to the left so that it now sits in the hundreds column, therefore we've got 500. The only difference here is we've got a negative 2, and the effect that has is rather than making the number larger than 5 becomes 500, we're going to make this number smaller. So in order to do that, rather than moving the digits to the left, the digits are going to move to the right. So the 5, if I bring down my decimal point there, is no longer going to sit in the units column. It's going to jump 1 place, 2 places to the right, and it's going to sit there in the hundredths column, having bypassed the tenths column, and I'll put a 0 in there, which is the position it was in. So 5.0 times 10 to the minus 2, 0.05. Let's have a look at a couple more examples. They're only sort of marginally more difficult, but not really. It's exactly the same process. 7.8 times by 10 to the minus 4. We know from what we've done here that the effect of this multiplying by a power of 10 is it's going to shift the digits. We know it's going to move them 4 places, and this negative here, the negative in front of the 4, means it's going to move it 4 places to the right in order to create a smaller number than 7.8. So let's do that. There's 7, which is in the units column, so I'm going to move it out of that units column, and it's going to go 1, 2, 3, 4 places to the right. 7. Don't forget the 8. We're going to bring all of this number down. So the 8, just as it did, sits to the right of the 7. And we now need to fill in our blanks with zeros in the tenths, in the hundredths, and in the thousandths. So 0.00078. Okay, slightly longer set of digits here after the decimal point. 2.483 times by 10 to the minus 5, 10 to the negative 5. The power of 10, it's negative, so we are going to move these digits to the right because the effect of it is going to be to make this number smaller. So bring down our decimal point. Let's work with the 2, and we're going to take it 5 places. 1, 2, 3, 4, 5. There's our 2. Just like we did here, the rest of the number, we're just going to write that exactly as it was to the right of the 2. And then we need to go and fill in all these gaps with zeros. So the 0 where the 2 was, and in the tenths, and in the hundredths, and in the thousandths, and in the 10,000ths there. So 0.00002483. If we have a look at the effects that these digit movements have had, we can actually start to see a quick way of doing it. This is a longhand way, and it's very useful to practice this. But in time, as with a lot of areas of maths, you'll start to find little shortcuts in your head and on the page. And if you notice over here, this negative 5, this 5 rather, not going to look at the negative for now, just this 5 bit. You'll know, if you look at the number, you've actually got 5 digits, 5 zeros before your 2, if we include the 0 in the units column. So that 5 corresponds to those 5 zeros. In exactly the same way, that 4 gives us those 4 zeros, including the one in the units column, and that 2 gives us the 2 zeros there before in front of our 5. And that's a quick way which you would aim to get to once you get a bit more familiar with the process of converting out of standard form when you're dealing with negative powers.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.